Hello everybody, and welcome back to our YouTube channel. Today we will learn the soil mechanics, basic but important. This is a really interesting topic. As some of you may know that the soil mechanics is very important, and for maybe you ask someone, they also told you that soil mechanics is very important and you need to learn it. So, but ask them, what should I learn? Or please give me some advice. And the answer maybe is that you should go to read the book, and they will give you some book like this, or 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 like this. And one book has thousands of the pages, so how to read it all? And that's why many of students, even you read it, even you learn the soil mechanics from university, but you forget it all, or maybe you remember but you don't understand it. And that's why we open this topic, to have everyone learn the basic soil mechanics, or review it if you have learned it in the university. So let's start it. As you may know, in the nature, soils are three-phase system consisting of solid soil particle, the water, and the air, or sometimes we call it the gas. And to develop the weight-volume relationships for a soil, the three phases can be separated, as shown in this picture. Based on this separation, the volume relationship can be defined. The void ratio is the ratio of the volume of voids to the volume of the soil solids in a given soil mass. And the porosity, N, is the ratio of the volume of voids to the volume of the soil specimen. And so we will make the relationship between the porosity and the void ratio. Actually, we have the porosity N equal to, this is the volume of the void divided by the total volume of the soil specimen. And we have here the total volume is equal to the volume of the soil plus the volume of the void. And we have final result. This is the relationship between the N and the E. The N is the porosity and the E is the void ratio. So we will get a definition of the degree of the saturation. So this is the degree of the saturation. Is the ratio of the volume of the water, the volume of the water to the volume of the void, generally expressed as a percentage. You see, we plus by 100% and we express it as a percentage. So the meaning of the degree of saturation, we can understand that the water is filled in fully of the void, or ether partly of the void. So that's the meaning of the degree of saturation. And we also know that if the water is fully filling the void volume, then we have the saturated soil, and the degree of saturation is 100%. So the next definition is the moisture content. Moisture content, W, is the ratio of the weight of the water to the weight of the solid soil plus 100. Generally, we express the moisture content as a percentage. So, one more important definition is the soil unit weight. The soil unit weight is the ratio of the weight of the soil to the total volume of the soil specimen. Mostly, we call it moist unit weight, or you just simply call it soil unit weight. Moist unit weight is mean that in the soil specimen we also have some water in it, and also have the definition of the dry unit weight. It means that in the soil specimen we take out all the water and only the soil solid remain on the specimen. So we now make a relationship between the dry unit weight and the moist unit weight. The soil density is the ratio of the mass of the soil to the total volume of the soil specimen. And also we also have the definition of the dry soil mass density. This means that we take out all the water from the specimen, and the weight here is only the weight of the soil solid, or the solid soil. And to calculate the unit weight from the soil mass density, this is the formula, and this is the formula to calculate the dry unit weight from the dry soil mass density. G is the gravity acceleration is equal to 9.81. So now we will consider the soil specimen. With the solid soil, the water content, and the air, the volume of the void is equal to the volume of the air and the volume of the water. So we consider the solid soil with the volume is equal to 1 unit. And as you remember in the previous slide, is E. This is the void ratio. You see the ratio of the volume of the void to the volume of the soil. Because in this case we have the volume of solid soil is 1, then we have the volume of the void is equal to E. And to explain this formula, we have here this is from the definition of the GS. GS is the specific gravity, is the ratio of the unit weight of solid soil to the unit weight of water. So that's why we have here the unit weight of the solid soil is equal to the specific gravity plus the unit weight of the water. It's easy, right? This is the explanation for the why the void of the volume of the void is equal to the E. This is the void ratio. And to specify, the weight of the water. This is from the definition of the moisture content. Actually, we have the moisture content is equal to the weight of the void divided by the weight of the solid soil. Weight of the water is equal to the moisture content plus the weight of the solid soil. But the weight of the solid soil is equal to Ts plus gamma W. So that's why we have this formula here. And also to explain how the volume of the water equal to moisture content plus the specific gravity of the solid soil. We also have here the volume of the water is equal to the weight of that water divided by the unit weight of the water. But we have here the weight of the water is equal to this. So we have the result is the moisture content plus specific gravity. And we also have case 2. This K1 is the unsaturated soil. This means that we have the water and the air here. But for this case, this is the saturated soil. There's no air in the soil specimen, and the water is fully filled in the void. So it's really easy because we already know from here, from the definition of the GS, we can explain this. And for this case, because we have fully water here, so the volume of the void is equal to E and is equal to the volume of the water. And we already have here the volume of the water is equal to the moisture content plus the specific gravity here. So we just take this to this and we have the result here. And it's really easy. So this is the table for some type of soil and the rice unit weight. Commonly you can refer to this even for the void ratio and the natural moisture content in a saturated state. For example, for steel clay, the dry unit weight is about 17. For soft clay is about from 11 to 14. And for the dense silty sand, I want to the dense uniform sand is about 18. And you can see that for the weak soil, the triunic weight is smaller than the stronger soil, the better, the good soil. That's some judgment we can have at the moment. So this is two examples. Example 1 and example 2, and this is the answer, and this is the answer. So please solve the problem and comment your answer and your solution. You can make it on your paper and take a picture and post in the comment content. In the next video, we will talk more about the example and some problem solved for this content. And thank you very much for watching the videos, and please subscribe, like and share to your friends if it is helpful. See you in next time. Bye bye for now.